ACL injuries are common among athletes. It is often caused by sudden movements such as pivoting or abrupt stops. To diagnose these injuries, analysts typically rely on MRI scans. However, interpretations can vary depending on the analyst's experience and perspective. This subjectivity can lead to inconsistent assessments and delayed treatments. To address this issue, we conducted a study using machine learning to classify ACL injuries. Our goal is to provide faster, more objective, and consistent evaluations by comparing three Ensemble learning models. We started with almost 1,000 knee MRI scans that is labeled healthy, partially injured, or completely ruptured. But there was a problem, that is, most of the data showed healthy knees. To help the computer learn better, we added more examples of the rare injuries using a technique that creates similar new data. It is called SMOTE. Then, we cleaned the data and made sure everything was on the same scale. We tested three smart systems or model to help with the classification. The first one is random forest, which are a combination of decision trees. Next is taking KNN or K nearest neighbors, which looks at similar examples nearby. And the last model is taking support vector machines or SVM, which tries to draw clear lines between classes. These models don't work alone, they combine multiple ideas to make better and more confident predictions. To make sure the results were fair and accurate, we repeated the test several times using different parts of the data. To see how well our models perform, we use confusion matrix. It is a simple chart that shows how many predictions were right and wrong for each class. Each row represents the actual condition of the knee, whether it was healthy, partially injured, or completely ruptured, while each column shows what the model predicted. Let's take class 1 as example. It is partially ruptured. In the second row, if the number is in the middle of the cell, it means that the model predicted partially injured correctly. If the number is on the left, the model thought that it was healthy, but it wasn't. If the number is on the right, the model thinks it was completely ruptured. The more numbers appear along the diagonal, the better, because that's where the model gets it right. From this confusion matrix, we can calculate two important scores, which are accuracy and F1 score. Accuracy is the percentage of all predictions that were correct, while F1 score tells us when the model predicts something, how often it is right, and how often does it miss in the real cases. The value of accuracy and F1 score for each models are summarized in the table shown here. Each model had its own strengths and limitations. Among them, stacking KNN gave the best results. So, based on this study, we recommend using stacking KNN for the future ACL classification task. But, to improve even more, we suggest expanding the dataset with more clinical and demographic information, also exploring another example methods.